Good morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and we are into our class number 2. Today, we are going to talk about many concepts which are actually means I would not say difficult, but people presume them that they are difficult, and people do not ask much question about them also because these are the concepts which we have read in our which we had read in our 12th or maybe 11th standard, right? But that is okay. Believe me, the important part of the live class is that if you even you don't get 2 plus 2 in that, please do ask. Nobody is going to judge you. If you ask question, it is going to be great. Today's session is the most fundamental session, but I have seen many network wireless engineers which face hard time understanding these concepts. Okay, so guys, please do ask question today. It's my humble request, and here you go. So agenda is going to be simple. As you know that we have divided our wireless problem into 4 parts, and we have been discussing about the medium because it is important for wireless engineers, right? Why? We will be talking about it. Then we are going to discuss about electromagnetic spectrum and RF signal. And you must be thinking, Mr. Vishnu, generally you do not throw terms until and unless you explain them. And it is my mistake, but that is fine. If you do not get what is RF signal, that is absolutely fine. No problems with that, right? But I just want to cover the agenda, and that is why I have written some names. Once we understand what exactly a RF signal is, it is not N, it is A. We are going to talk about its characteristics. We are going to talk about what are the things which constitute these RF signals. Okay, wavelength, frequency, amplitude, phase. We will be talking about it. And one of the most important piece for today's wireless engineer is to understand the concept of phase, right? Which we do not get. Believe me, we will be talking about it. If time permits, we are going to talk about RF behavior also. For example, wave propagation, absorption, reflection, refraction, multipath, and so many things. But if time permits, and believe me, I just have an experience from the Hindi class that time is not going to permit us. But whatever we are going to read in the next 1 hour and 15 minutes, it is going to be with you forever if you just give me your 1 hour and 15 minutes attention, or means you can order tea, coffee, but just have your full attention in today's class. Having said that, let me remind you what we discussed last week. Okay, it was very simple. Here we have Mr. Hertz, who was successfully able to showcase to this entire world in 1887, right? Or that he can send he can send energy from one place to another place, even if we do not have air. Also, if we do not have any medium, if we do not have anything between this plate and this wire here, the circular wire, and this guy was successfully able to send this energy from one place to another place. It is invisible energy, right? And when somebody studied about it, of course, 20 years back, Mr. James Maxwell, right, he talked about it that actually this energy is just nothing but electrical energy and the magnetic energy, right, which is flowing in the air, which doesn't require any medium. We have discussed about it. It was pretty easy experiment, right? And today we have to understand more about this energy, right? We have to think about that if energy can go, can our bits, ones and zeros also can go on top of this energy? If it can, then my problem is solved, because the most important project on which our two characters, Anjali and Rahul, are working is to wireless their complete campus network, right? And this is our aim. And to understand this and to implement this, Anjali is reading all about wireless networking along with us. Having said that, so this was the recap. Uh, and today we will be starting why it is absolutely important to understand this medium in detail, right? So as you all know, we are actually talking about this medium, right? And we have to. So first thing first, let's identify why there is a need to understand this medium, because you can argue with me that Mr. Vishnu, when we have two computers, computer number A and computer number B, right, and we connect them with a wire, and even you don't believe that we have connected the entire computers of this world through this wire, right? And we don't generally study how my bits are flowing over this wire. I am a good network engineer, but I do not know how exactly the bits are flowing in the form of current, or maybe how. I do not know. What is the modulation? I do not know. But still, I am a good network engineer. Why you are saying that we need to understand this wireless medium if I want to be a good network wireless engineer? So here is the answer for that, right? Because why, or understanding why behind everything is really, really important. And now I am explaining why you need to understand this medium. And the answer is simple. The answer is, if you are sending data over this wire, right, there is no need to worry, because at the end of the day, whatever you are sending, electric current or anything, it is confined, or it is going to be remain inside this wire, and that is it. So we have a fixed medium. But the problem of this wireless medium is it is not confined to a particular region. If you are sending energy, this energy is going to be everywhere. Just think about the sun, right? The sun is radiating energy everywhere, right? How you are going to control this medium? And then you must be thinking, Mr. Vishnu, why do we want to control this medium? Because you need to send these signals, this energy, right, to a particular device which will be near you, right? And you all know that our normal switch does not understand the wireless thing. What we do in case of normal switch, we connect a wire, we connect our laptop and PC, and then we start sending the signals, or the sending the ones and zeros over it. But now here is a big problem. The problem is now Anjali is sending everything over this energy, which is discovered by Mr. Hertz, right? And then he successfully proven that energy can flow from one place to another place without any medium. If Anjali is going to use it, the the device who will be capturing it is going to be the switch. But my problem is switch doesn't understand it, and that is why I am going to need a new device, right? Or you can say I will be needing a new device, and this device important characteristics are that it will be taking the data from this wireless medium, from this energy, and then this device will be sending this data over this wire, as simple as that. So in this, it understand both the things, wireless medium as well as wired medium, right? And after some time you will be knowing this device with a name, which is and the name of this device is access point. Amazing device. It understands wired as well as wireless. One end of this device is going to be connected with my switch. The other end is not connected anywhere, right? It is just carrying the messages. It is just carrying the packets from the air, right? Everything is in air now, right? And I'm explaining you the reason why we need to understand this medium. We need to understand this medium because unlike a wired medium, the energy is everywhere, right? And if you want to design a wireless network, you need to understand where exactly this energy is. For example, if this device or this access point is sending a packet towards me, and I am not near to this energy, then this energy cannot reach to my laptop. And if that is the case, if this energy doesn't reach to my laptop, then I'm not going to receive this message. I'm not going to receive this packet. And if that is the case, this guy is never going to receive the packet, and it's a problem, right? So we need means if you are a network wireless engineer, if you want to design your wireless infrastructure, you need to understand this medium first, right? And this is where most of the this is where the this is the problem with the many of the network engineers, that they do not understand this medium very well. And the whole sole point of today and tomorrow's class is this medium, getting this medium, going into this medium to look what exactly this is, right? I have made the sun and basically few circles around it. It is representing that the sun is sending its energy everywhere. It is a sphere, right? It is sending its energy everywhere, right? And we need to understand this energy. Okay, similarly, this laptop, whatever Anjali is having, believe me, it is going to have, it contains some antennas in it, which are radiating energy, which are sending continuously energy, right? We need to understand where this energy or where my data is going, because at the end of the day, I will be sending my data over this energy. And the process is known as modulation. I think you all, someone from you have asked this question, that Mr. Vishnu, are you going to teach us modulation also? Absolutely. We will be talking about how we are going to send our ones and zeros over this energy, right? Having said that, let's discuss about this medium a little bit in more detail, right? And here we are going to talk about how we can understand this medium. So this picture should be always in back of your mind, this picture, right? Anjali wants to send some data to this new device, which is access point. This is going to be connected with my switch. As simple as that, right? And we are just planning to understand this medium. So this picture should be in your mind right now. Where we are with respect to this complete wireless course. We are just studying this medium. Now my point is how to study this medium, right? And this was the problem in somebody's mind also. And he has just suggested some fantastic thing. He's saying that this is a real problem. For example, if we consider the sun, right? Sun is radiating energy in all direction. You see this energy, right? In the form of visible light, the white color light you see, right? And sun is quite far away from us, but still the energy from sun is flowing from the sun towards the earth. You all know that, right? We feel that warmth, we feel that heat, right? Every day. And in today's time, today means you all know in northern part of India, the temperature is 50 degrees Celsius right now. We can feel the heat of sun, right? It means that the energy is flowing from the sun towards earth, right? And you all know there is nothing between earth and the sun. This is complete vacuum. If we leave some portion around the earth, which is its atmosphere, then everything is the place where there is no earth also. It means that energy is flowing in the vacuum. And now the question arises, how we are going to study this energy? Similar kind of energy is generated by Mr. Hertz, right? He has accumulated charge on a particular surface, which produces a spark, and then the energy flows from here to this place. We understood this experiment, right? And this is the similar behavior done by Mr. Sun, right? It is sending or radiating energy everywhere. We can feel that energy. Now the question arises, how we are going to study this signal or this energy which was produced by Mr. Hertz, or which every day produced by the sun, right? So somebody has suggested that you can understand this energy if you can presume them or you can assume them, right, as a wave. You need to consider them as a wave if you want to understand them. And now the question arises, Mr. Vishnu, wave, why wave? So somebody gave this idea that if you throw a stone in the water, right, you will see the ripples coming, right? It means that the energy is flowing outwards like this. And of course, if you move away from this, right, the energy, you will feel less energy. The energy will be concentrated more right on the center. You all know about it, right? Similarly, saying the radiations, the energy which is coming out of the sun, right, it is more near the sun. And as it goes to earth, its intensity is going to be down, or this energy will be down, right? If you compare it with the sun, right? So this guy says that if you want to study it, it's a really huge problem. How you are going to study the sunlight, right? Which is visible thing for you. How you are going to study, and if and physics, or basically the engineering, is all about learning or understanding what is happening around you, right? Right now we are understanding wireless engineering or wireless networking, right? We need to understand the medium. If we need to understand the medium, this guy is saying understand the waves, because many of the characteristic of this energy is just like a wave. If you get the wave, then you can understand this energy too. And now you can ask me, Mr. Vishnu, why wave, right? Because some scientists said, for example, Mr. Einstein said that the energy which we are getting from the sun, or these electromagnetic energy, is actually a particle. And you must be thinking that, Mr. Vishnu, if something is particle, it cannot be wave. If something is wave, it cannot be particle. And believe me, it is a huge debate even right now. Nobody understood this, whether the light is a wave or it's a particle, because some of the things of the light can be explained well when we understand it as the particle, right? But many of the characteristic of this light can be explained well when we understand it as a wave, right? So today we are not going to consider this energy, this light, as particle. We will be understanding this light or this energy from the viewpoint of wave, right? And that is why we will be studying some of the properties of this wave. And by the way, what we are doing, you just have this thing in back of your mind that we are talking about this medium. Anjali, try to understand this medium. Somebody suggested if you want to understand this medium, you need to understand using a wave, because most of the time this energy or this medium behaves like a wave. As simple as that, right? If you get this point, let's talk about this wave in greater detail. But before that, I would like to showcase you that the sun is radiating many different type of these radiations, right? Or this energy. And if I would like to showcase all that energy to you, right? We know this energy with the name electromagnetic spectrum, right? And believe me, whatever the thing you see, right? For example, sun is radiating so many energy, right? Or so many electromagnetic waves, right? You are seeing if it is radiating this much of energy, you are only able to see this much portion. That is it. And that is known as the visible light. Whatever the white light you see, right? Which is consist of all of these colors, red, or you know the Vibgyor, right? Violet, indigo, blue, all the colors, whatever you see because of this light, right? This is the visible portion of this spectrum. So whatever sun is radiating, if we combine everything, right, it is basically electromagnetic spectrum. So do not get confused with the Hertz experiment and the sun, because sun is the ultimate source of energy. It is radiating so many radiations, right? And if we study them, if we draw everything on the on a piece of paper, then basically we get electromagnetic spectrum. The thing which you see, it's really small piece of this electromagnetic spectrum. Believe me, there are other things beyond that which you even can't see. For example, there are other type of energy, which is X-rays, gamma rays, infrared rays. If you have used, and definitely you must have used your remote control, right? If you press a button, something comes out of it. You can't see it, right? But it does its function. It can control your TV. That is your infrared rays. If we talk about microwaves, right? Microwave, whatever the microwave you see at your home, it is working on this principle. If we talk about communication, communication happens over radio waves, and believe me, you cannot see them. You can see only a limited portion of this spectrum, which is the visible light. Apart from this, you cannot see this, right? Okay, so we all know now that if we consider sunlight, if we consider the radiations which are coming out of the sun, right? Or maybe the radiations which was produced by Mr. Hertz, right? Mr. Hertz can produce any of these radiation. You do not need to bring sun here for your wireless communication. Believe me, if you want to generate these signals, I will let you know how to generate these signals. These signals can be generated with the use of electric current very easily, right? Because Mr. Hertz supplied electric current. As a result, he was able to produce this energy, which is known as electromagnetic energy. And if you can see it, that energy will be somewhere into this spectrum. So spectrum consists of everything, right? Whatever you see is the visible light. And there are many other things which you do not even see, right? And that is why we say it wireless. Everything is happening in air, right? Your data is going in air, right? Even without air also, right? So now, if we talk about how we can generate this signal, right, or this wave, it is very simple, because at the end of the day, what we are going to do, we will be having one computer here, right? We will be having another computer here, and suppose we want to communicate between them. What is going to happen? This laptop will be generating this radiations, or maybe this energy, right? This energy, because somebody has suggested, it is going to be very easy if you understand them using a wave. So I am drawing this wave. So this wave will come out from here and will be reaching to this B, right? And this wave will also be carrying data. How we are going to carry data over this wave, or how we are going to carry data over this energy, is totally different concept, which we will be talking about in modulation. Believe me, it is going to be really interesting, right? We can send data over this energy, over this wave, and this data can be read by this B, right? What is the prerequisite? The prerequisite should be that this guy should be able to generate this wave, and this guy should be able to receive this wave to get some information out of it. A can send something, or this energy containing some data, and B is going to fetch the data from this energy. As simple as. Now the question arises. How on earth I am going to generate this? Mr. Hertz had solved this problem in 1887, guys, right? We are using it right now. So what we are going to do, we will be having this strange looking device, right? It is just nothing, but uh, it is made up of metal, right? And metal contains, you all know, that metal inside a metal, electric current can flow, electrons can flow, right? You all know about it. And what I've done is I have connected, and I'm calling this green device, whatever is this, as antenna. What is the meaning of antenna? I will be talking about it, right? But for now, you consider this device is just a metallic body where inside which electron can move freely, right? And now we have something here of red color, which is my red wire. Again, this wire can carry electric current. Which current? Alternating current. If you're wondering what is the alternating current, believe me, whatever current comes to your house from the power grid is actually alternating current. Sometimes it is positive, sometimes it is negative, right? And you must be thinking, Mr. Vishnu, don't you think it is a wave-like structure? It is a wave-like structure, right? So if you want to study more about alternating current also, you need to understand this wave, right? Very, very interesting. See, what we are going to talk about, we are reading about this medium. Medium is kind of a wave. If you want to understand this medium, we need to understand wave because it is most of its property are like a wave. And alternating current is also wave. Sometimes it is positive, sometimes it is negative, right? And this is the AC source. The meaning of AC source is, the meaning is that it can generate alternating current. And this alternating current can go into this wire. And then this wire is connected to this antenna, which is of metallic body, right? It means that electron will start flowing into this wire, sometime in downward direction, sometime in upward direction. Why? Because alternating current is changing, right? Positive, negative. And that is why current is going to change in this antenna. And if you do not know, just try to understand. If current is flowing over into this wire, it is going to create magnetic field. If current changes its direction, magnetic field is going to create electric field, then again magnetic field, then again electric field. And this is what Mr. Hertz had explained us, right? It means that if I connect a wire to this antenna, right? And if I give a AC signal or alternating current to this antenna, it is going to produce electromagnetic waves. Very, very interesting, right? And if this antenna is generated, because electromagnetic spectrum is huge, right? We are interested in generating radio waves. Why radio waves? I will be talking about it because we haven't understood their property till now, right? We can use radio waves in our communication. I will tell you why, on what basis we are going to use them in our communication, right? But first thing first, we can generate these radio signal or radio frequencies. I haven't explained you the concept of frequency also, but if I'm talking about an RF signal, the meaning is radio frequency signal. The meaning is radio waves, right? So overall, I have a AC source. If I give alternating current to it, it is going to produce RF signal, right? And now the people get confused. Mr. Vishnu, what is RF signal? Are you talking about this signal is RF signal which is coming out of the antenna? Yes, this signal is the RF signal, but who is the generator of this RF signal? And you must be thinking, Mr. Vishnu, this electric current, whatever you are supplying, it is again a wave, right? We can also say this as RF signal because eventually this signal, this alternating current is generating your RF signal. So something which is coming out of this antenna is RF signal, which you are giving in the form of alternating current is also your RF signal. And after some time, you will come to know about it, right? That many of the properties of this signal, alternating current, right? Because eventually this signal has generated the RF signal right here, right? Many of the properties are going to be same. It is going to be very, very interesting. Now, what is going to happen? This antenna will be radiating this energy in the form of electromagnetic waves, which can travel in the air or without an air, and this can reach to the antenna. And if you see that you have one laptop here, believe me, if you open the lid of your laptop, right, the top part of your laptop, if you open it, don't try this experiment, but believe me, this is going to contain the antennas, right, inside this lid, right? And this antenna can generate radio frequency or RF signal, which can go into the air. And then here we have the antenna. Here the antenna is doing exactly opposite. Believe me, It can generate the signal and it can catch the signal also, right? So here what is happening? From electric current, you are generating RF signal. Here what is going to happen? RF signal, from RF signal, you can create electrical signal, right? And try to understand, when two computers communicate over a wire, this wire will be carrying ones and zeros in the form of electric current. And if there is an information in this energy, how to do that, I will be letting you know. But if we can transfer, if we can get this electric current out of the RF signal, then we can also read bits from it, or we can send bits over it. Very, very simple, guys. It is amazing thing, but this is how the things happen. This is just the Hertz experiment, but this is how exactly communication happens, right? So the whole sole point is, take away from this board is, what is the meaning of RF signal? The RF signal can be your AC source. The RF signal can be the one which is generated by this antenna. As simple as that. Now the whole sole point is this, whatever we have generated right here in the form of this wave, we are going to study more about it, right? Now we know we can generate this signal. This signal can go from one place to other place at a very high speed. I'll let you know the speed in today's class only. But the point is, what about this signal? Can we talk about more of this signal, right? Because somebody has said that you can read this signal, RF signal, right? You can read this signal if you can understand a wave, right? Because this is behaving like a wave. If that is the case, first property, first characteristic of this signal is wavelength, which we will be talking about right here. So what is the wavelength, guys? You all know our RF signal is going to behave like a wave, just like this. This portion of the wave, just wait a minute. Okay. This portion of the wave from here to here, the peak, this is known as the peak here, and this is known as the valley. Peak is also known as the crest, and this valley is also known as the trough, right? If you take two successive crests, this is, and the another successive one is this one, because this is going to be a trough, right? And if you take the distance between them, the distance between two successive crests is known as wavelength. Very, very simple. This is represented by a symbol which is known as lambda. As simple as that, right? Or you can say, Mr. Vishnu, can't it be the distance between two trough? Yeah, it is going to be same, right? Again, this is the lambda, right? And if it is a distance, then the unit of distance is meters. We can say maybe this wave has a wavelength of 2 meters. Believe me, it has a significant importance. I will be talking about. But first, we are going to talk about some of the characteristic of this radio frequency signal which came out of the antenna. Or maybe RF signal is the one which is the alternating current also, right? We need to understand it, and that is why the first thing which we are going to talk about is the wavelength. And I think you understood about the wavelength now, right? But somebody said that it is always necessary to study or to measure this wavelength in terms of meter. Can't we measure this wavelength in terms of degrees? And then you must be thinking, Mr. Vishnu, what is that? Why degrees, right? Well, okay, let's try to understand it, right? So we have a circle here. If we go back in time, there was some Greek scientist, I do not know the name, who had divided this circle into 360 different pieces. And they call one piece as 1 degree if they calculate from the center, right? And this is also the angle which you read, right? 1 degree, 2 degree, 3 degree, and you may fight with Mr. Vishnu, why 360 only? In today's world, we can divide it into 1,000 equal parts also. You are correct, but this is the convention, right? And most of the mathematics is based on this. So we will be following this convention, right? So a circle can be divided into 360 degrees, right? And now, if we talk about a wave from here to here, right? If we talk about from here to here, can I divide into 4 parts? For example, I can divide a circle into 4 parts. This one is 90 degree, this one is 90, 90, and 90. Or you can say 90 degree, then 180 degree, then 270 and 360, right? If I divide this wave into 4 pieces from here to here, it is going to be piece number 1. From here to here, it is going to be piece number 2. From here to here, it is 3. And from here to here, it is 4, right? And I can say this is 90 degrees, this is 90 degrees, this is 90 degrees, and this is also 90 degrees. Combining them, it's going to be the 360 degree. Just like we have divided a circle into 360 different parts, we can divide a wave also into 360 degrees, right? But you must be thinking, Mr. Vishnu, meters were easy, right? The distance between two successive clusters, that is fine. Why degrees? Because this is where most of the wireless network engineers get confused when we talk about phase, right? When we talk about some modulation technique which is dependent on these degrees, right? Believe me, this concept is this much simple only because we do not know this. That is why we face hard time to understand phase modulation, right? Modulation is just nothing, guys, but how you are going to send your data over this RF signal. We will be talking about it. And we can send data very easily. For example, just try to understand if there are two computers, right? And if we connect them over the wire, are we sending real ones and zeros? No, absolutely not. We are just sending maybe electric current. Maybe sometime we say, I am sending you 5 ampere of current. And if you get the 5 ampere of current, understand that it is a 1. If I am sending 1 ampere of current, understand it is a 0, or maybe 0 ampere of current, understand it is a 0, right? Similarly, we can send different phases. We can send different wavelength or maybe some other things, right? Frequencies also. We will be talking about modulation in detail. Do not worry about it, right? So the whole sole point here is this wavelength can be measured in meters, centimeters, whatever the unit of distance is. But this wavelength can be measured in terms of degrees also, because if we consider one wave, right? It is a 360 degree. If you can divide it into four pieces, 90, 90, 90, 90. I will be talking about it. So in the meantime, I can see that 36 minutes have been passed. If you guys have any doubt, any problems, 2 plus 2 is equal to 4 is not making sense to you, please do ask. But till now, I think we are good because I do not see any hand raise here. If that is the case, now the time is to talk about something more with respect to this wavelength, right? So in wireless networking, many people says that we have 2.4 gigahertz signal. We have 5.7 gigahertz signal. What is the meaning? We do not know till now because we haven't discussed what is this gigahertz is, what is this frequency is. But we understand now that if we have a wave, it is going to have some distance. So I am going to tell you, because you all know 2.4, 5.7, right? If you see your wireless router, it works on two different frequencies, 2.4, 5.7. We haven't discussed frequencies yet, which I'm going to do. But for now, I think you all understand that 2.4 and 5 point something is two frequencies which this router shows us, right? I would like to showcase you that these are going to be your two different signals, right? If we talk about 2.45 signal, right? It is having 2.24 centimeters. 2.2 centimeters of what? It is having 2.24 centimeters of wavelength from here to here, or maybe if I increase it, then basically from here to here, the distance is going to be 12.24 centimeters. By the way, 1 meter is equal to 100 centimeters. You all know about it, right? Interesting. And now if I talk about 5.775 gigahertz signal, it is 5.19 centimeter. It means that the greater the gigahertz of a signal, the lesser the wavelength, right? But why we are talking about it? Because generally, Vishnu, you can ask me, generally, Mr. Vishnu, you do not explain us something until unless you have explained it well, right? For example, you don't take even the name, but why you have taken this name of gigahertz? What is the meaning of it, right? So first thing first, to understand this gigahertz, we need to understand what is the meaning of this giga, kilo, or maybe mega, right? Let's talk about the units first. And having said that, it is very, very simple. If we talk about RF characteristic, and we are still talking about the wavelength. So right now, if I talk about kilo, the kilo means anything, right? The kilo, if something comes to your mind, then it means multiply by 1000, means three zeros after one, right? If I talk about mega, it means multiply by six zeros after one, right? It means 10 lakhs, you can say. If we talk about 1 giga, it means multiply by 9 zeros after 1, 10 to the power 9. Interesting, right? And by the way, 10 to the power 9 is actually in um, English counting, it is 1 billion. Okay, giga is billion. And after this basically, you must have noticed that we are increasing zeros by 3, means from kilo to mega, 3 zeros got increased. From mega to giga, 3 zeros got increased. If we talk about tera, peta, exa, and many more, you just increase 3 zeros, right? And examples are simple. If I talk about kilometer, it is going to have 1000 meters, because we are having kilo of meter, and kilo means multiply by 1000, and that is why we are saying it is 1000 meters. Megawatt, mega means 10 to the power 6. It means that it is going to contain 1, then 6 zeros after this, means 10 lakhs or 1 or maybe 1 million, right? This many watts. If we talk about gigabyte, then 9 zeros after 1 bytes, right? Very, very simple. So these are the units which are quite of means quite big unit. But what about if we have something very small, right? For example, many people says that if we have these two router number one, router number two, and OSPF neighborship is running between them, they want something that if this neighborship goes down, I should know in less than 1 second. And you must be thinking, Mr. Vishnu, what is less than 1 second? We do not know, right? Because we cannot process it. If somebody say 0.0001 second, right? You must be thinking, Mr. Vishnu, my mind is not going to process, right? But it is now beyond our mind, because R1 and R2, these are two computers, guys, right? And if these are two computers, they can process the information even, right? They can process this information even way lesser than 1 second, because most of the people say we want sub-second failover. What is the meaning of sub-second failover? The meaning is that if OSPF neighborship goes down, I do not want to wait for 1 second to know about that this neighborship is down. I want to know maybe in 0.5 second, maybe in 0.0001 second, not me, these routers, and I can take action on the basis of that. So for that, if you go down, that basically 1 second or 1 second is going to have 1000 milliseconds. Really, really interesting, right? So if we multiply something, then basically kilo. If we divide something, then basically it is milli. Then it means that it has divided 1 second into 1000 equal parts. Then micro, the meaning of micro is 6 zeros after 1. Then there is nano, 9 zeros after 1. These are important, right? Now I don't think that you have any means. If I tell you 2.4 giga, you must be thinking Vishnu is talking about 2.4 into 10 to the power 9, because giga means 10 to the power 9, right? And now we are in pretty good shape to understand the next concept, which is frequency. So what is the meaning of the frequency, right? Let's talk about it now. Here you go. Try to understand this. Now let's take an example. Suppose you are in your home and this is your home window, and maybe you are somewhere here looking from your window, right? And there is a railway track, maybe 1 kilometer apart from your house, and you can see that track, by the way, and you can see the train going over it, right? And there are many trains in a day which goes out, and one day you have decided that today I am going to count how many trains are passing, right? And then you have calculated that there are 48 trains that pass, right, in a day. And that is why basically you are saying that the trains are passing frequently, right? If something is happening again and again, you are saying it is frequent. And actually, it is coming from a word frequency, right? You can say the train passing frequency from my window, from my house is 48. But what 48? 48 per day, you are going to say. Interesting, right? Similarly, if you take a motor, then the motor revolves, right? If you count how many turns it take in 1 second, then basically it is representing its frequency. For example, it can turn, it can cycle 1000 rounds per second. What is this? This is the frequency. So Mr. Hertz came and he says how many times an event happening in 1 second is known as frequency. So he has defined, right? Because some people would say that this is basically one day. It is happening over the period of one day or maybe 1 year. There must be some standardization. So Mr. Hart said that if something is happening again and again, right, in 1 second in 1 second period, just count it, and it is going to be your frequency. As simple as that. But why we are studying it in wireless engineering? Because at the end of the day, this signal is a wave, right? Just like this. I want to know in 1 second how many times this wave is going to pass through, right? And you all know that one wave, if I calculate, it is going to be from here to here. So one wave, two, three, four, five, six, and seven. I can say 7 waves are passing in 1 second. It means that the frequency of this wave is actually 7, and because it is happening in 1 second, its frequency is going to be hertz. So the frequency is going to be 7 hertz. As simple as that. Right, guys? Now let's take another signal. If we count here, 1, 2, 3, maybe 4, this wave is passing 4 times, right? In 1 second. It means the frequency of this wave or the lower signal is only 4 hertz. But there is going to be something very interesting happens if you combine frequency and wavelength. And you must be thinking, Mr. Vishnu, what is the point? What is the meaning? So if I say how many waves are passing, it means that I want to say how many wavelengths are passing, right? The distance between two successive valleys is known as the wavelength. And suppose the wavelength is 3 meter for this wave, right? Really interesting. And if I say the frequency of this is 7 hertz and the wavelength of this wave is 3 meters, believe me, if you multiply them, 7 into 3, right? 7 hertz means this wave means 3 meter wave is passing 7 times, right? In 1 second. It means that how many meters there are going to be in 1 second, how many meters this wave is going to travel in 1 second. It will be 7 into 3 means 21 meter will be traveled by this wave in 1 second. And what is this meter per second, guys? This meter per second is just nothing but the speed. This means if you want to calculate the speed of this wave, you just need to multiply its frequency, which is denoted by this number f, and then with lambda. Lambda is what? Lambda is your wavelength. Do not worry about these symbols. These are easily. We need to have some numbers to represent, right? We could have represent wavelength this W, right? But maybe W was used by for something else. That is why they were using this lambda. But it is just a way of representation, right? Again, just try to concentrate more on this. If I am saying this signal frequency is 7, right? The meaning is absolutely simple. Meaning is this signal is passing through 7 times in 1 second. And if I say one signal, the meaning is one wavelength, and one wavelength is equal to 3 meter. If I multiply 3 meter with the frequency 7, it is going to say that from here to here, the distance travel is 21, and 21 in what? 1 second, 21 meter per second, which is the speed of this wave. As simple as that. That is why we are calculating the wavelength as well as frequency so that we can combine them together to know some cool things. Really interesting, right? Now, let's talk about a very important property of this frequency and wavelength, right? It is mind-blowing experience. Just have a look at this diagram, right? What is happening here? We all know that we have Mr. Sun here, and Mr. Sun is emitting so many radiations, so many uh, uh, energy, so much of energy, and this energy is going to be reaching to Earth in approximately 8 minutes and 20 seconds, right? Believe me, the speed is huge. This energy travels with a huge speed. And what is the speed? That speed is 3 lakhs kilometer in 1 second. I'm not talking about 10, 20, 30. Even 30 kilometer in 1 second is a huge speed. I am talking about the speed with which this energy comes from sun to earth is 3 lakhs kilometers per second, and nothing can travel faster than this. And this is at least basically today's human. Uh, Today human says that basically nothing can go faster than this, right? 3 lakhs kilometer per second, right? And you all know that these are whatever the waves or whatever the electromagnetic energy which is coming out from the sun, it is just the electromagnetic wave. And see the speed is huge, right? And still it is going to take 8 minutes and 20 seconds to reach. It means that you can easily calculate how many meters away or how many kilometers away sun from us, right? It's a huge distance. Really, really interesting, right? Now, let's talk about, I would like to showcase this relationship once again, the distance, speed, and wavelength, because it is really interesting and important for our course. So what is happening here? We have a car, right? And we have basically this road. This road is 100-meter long, and this car basically traveling with a speed, certain speed, and it crosses this road in just 10 seconds. Believe me, right? If that is the case, if I want to calculate the speed of this car, it is going to be speed is equal to distance upon time. You all know about it, right? The distance here is 100-meter and time is equal to 10 seconds. Then basically we can reach that its speed is 10 meter per second. We all know about it, right? Now consider a wave, right? Its frequency is 5 hertz. Its wavelength is 10 meter, right? What could be its speed? We all know the meaning of frequency is, if it is 5 hertz, the meaning is 10-meter wavelength wave, right? It is going to 10 meter, is passing 5 times in 1 second. If we multiply them, 5 into 10, it is going to give me 50. It is going to give me, sorry for this, 50 meter per second, right? So here what we are doing, speed is equal to wavelength into frequency. That is it. Really, really interesting, right? And please do not think that I am teaching you physics. Eventually, in tomorrow's class or day after tomorrow's class, we will be doing some mathematical exercises, because most of the wireless engineers' problem is that they do not understand all these things, because eventually you need to do some mathematics to calculate, to design your network well. Although some tools are available, right? You can always argue with me. It is as good as saying that there are many tools which can do IP subnetting for you. There is no doubt about it, right? But still, we would like to understand subnetting. And the reason is because if you understand subnetting, you are a better network engineer. You know, right, how IP works. You know how routers work, right? Similarly, we are actually trying to calculate some of the things of this medium so that we can be a better wireless engineer. Okay, so do not consider at any point we are going away from the topic. We are right on the topic. Do not worry about it. We are studying medium, and to study medium, we need to understand some of the mathematics, some of the physics of this medium. But believe me, if you get this, you do not need to understand many formulas of physics. This much is more than enough, right? But now I will going to showcase you one specific wave whose wavelength is actually, just wait a minute. Let me a little bit reduce the size of it. So I think you all can calculate right now, right? So have this picture in your mind, this picture. Sun is sending electromagnetic waves. Sun is sending energy towards us, which is reaching in 8 minutes 20 seconds, right? And this energy is traveling to 3 lakhs kilometer per second. Now my point is that we have one electromagnetic wave, right here. This electromagnetic wave has the wavelength of only 0.1 meter, guys, only 0.1 meter, but the frequency is 3 gigahertz. I'm talking about gigahertz. It means that this signal is moving 3 gigahertz time in 1 second, right? See the speed, right? See the frequency of this signal. How many times it is repeating itself in 1 second? It is 3 gigahertz time. It means that 3 into 10 to the power 9, because giga means 9, right? Hertz. And you all know if we multiply frequency with wavelength, which is 0.1, which can be written as 1 by 10, right? Then it is going to give me what? It is going to give me speed. Speed is equal to, now, if I cancel 10 with this, then it is going to be 3 into 10 to the power 8 meter per second, as simple as that. Interesting. And what is this? This is speed of light, which we just talked about. And here is one important thing. In case of electromagnetic radiations, RF signal is again your electromagnetic radiation. If you multiply wavelength with frequency, it is always going to give you the result 3 into 10 to the power 8 meter per second, because electromagnetic waves move in vacuum with this speed. Right now, the frequency is 3 gigahertz and wavelength is 0.1. That is why the speed is this one, and this value is constant. You can argue with me, Mr. Vishnu. It is not the case. In vacuum, the speed of light is this much, but in air, it is somewhat less. In water, it is way lesser than that. And if you have some other denser medium, it is going to be way lesser than that, right? But I'm talking about vacuum. Believe me, in vacuum, any electromagnetic wave is going to have this speed, right? And now try to consider your laptop is sending this wave RF signal at a speed of this light, right? At a speed of this much, 3 into 10 to the power meter 1 second. I'm talking about 3 lakh kilometer in 1 second. And you see your access point are just nearby, right? But if we talk about the distance between from here to US also, if we go at this speed, 3 into 10 to the power 8 meter per second, right? It can move in a flash, right? See the speed of this communication. It's huge, right? And by certain mean, for example, if you change this 3 meter to 2.5, then obviously, if you have decreased the frequency, you all know that the product is going to be 3 into 10 to the power 8. It is the fixed value. Then, of course, if you are reducing frequency, then the wavelength is going to be increased, right? If you have increased the wavelength, then the frequency is going to be decreased. And that is why there is an inverse relationship between frequency and wavelength. If frequency is increasing, wavelength is decreasing, and vice versa. And you all know, because their product is going to be always 3 into 10 to the power 8, right? Now, if I would like to showcase the spectrum diagram again, it is going to make more sense, believe me, right? So let me move to the spectrum diagram once again. Just wait a minute. Okay, here, right? So if you see here, in case of electromagnetic spectrum, here to here in the green color, we have radio waves. And in case of radio waves, you can see the frequency is less, right? Why? And the wavelength is more. But if you see in the case of gamma rays from here to here, from here, right? Here the frequency is more. And the distance between two crust or trough is less. So wavelength is more, then frequency is less. And in the radio waves, we are talking about frequency of 2.4 gigahertz, which is again a huge frequency. Then now try to consider what is the frequency of these guys of the gamma rays, right? It is huge. And that is why it is harmful for human beings. If you have heard about the nuclear explosions, right? The most dangerous effect of the nuclear explosion is because of these gamma rays, because they can penetrate, right? They can cause harm. Interesting, right? And why don't harm us? Because you all know, right? If you don't know, then I would say, if whatever we are teaching now, it is sparking something in your mind, then please do not let that spark go down, right? Just read about it. I think it is making more sense now. So we have studied about this medium and the two properties of this medium, which is wavelength, and the second one is frequency. The third one is amplitude, which I am going to talk about just now, right? So in the meantime, while I'm moving the board, if you have any doubt, any problem, please ask me, right? But now it is time to understand the medium, right? Sorry, the amplitude. Believe me, just 5 more minutes and then we are done. I know that it is too much for today, right? But believe me, there are many such concepts which we need to understand. Right now, we are just understanding the medium. So right now, if I talk about what is the meaning of amplitude, if you see what Mr. Hertz said, Mr. Hertz said this signal is just nothing but electric field and magnetic field. So if I talk about electric field, from here to here, the electric field is the strongest, right? From here to here. If I say that this is the electric field component, right? From here to here, it is maximum. So the distance from here to here is known as your amplitude. But what exactly amplitude is showing? Because I can understand wavelength is the distance between two crusts. Frequency is how many times the signal is vibrating, right? What is the meaning of amplitude? The meaning of amplitude is the power associated with this signal, right? The more the power, the more distance can be traveled by this signal, right? and we will be talking about it. For example, if we have a laptop or a mobile phone, right? These mobile phone and laptop are going to radiate this signal, but with what power, right? If laptop is radiating with more power, it means that its amplitude is going to be more, otherwise not, right? So amplitude represents power, as simple as that. Now, the last thing which I would like to tell you, and we have discussed about it also previously, is the phase. Basically, phase is not related to only one wave. Phase is comparison between two different radio signals or RF signal or two radio waves, right? And I have mentioned that if I divide this wave from here to here, let me choose some other pen, right? Maybe the yellow one, from here to here. If we divide it into four parts, just wait a minute. If we divide it into four parts, then this from here to here, it is going to be 90. From here to here, it is going to be 90. From here to here, it is again going to be 90. And from here to here, 90. And that is why I can say the length is also can be measured in 360 degrees, as simple as that, right? But you must be thinking, Mr. Vishnu, then what is the meaning of this phase? The phase can be understood only if you compare to different signal of the same frequency. I'm repeating, the frequency should be same, right? And the next board is going to explain exactly that. What is the meaning of the phase, right? So I am naming these signal. This is my signal number 1. This is my signal number 2. And this is my signal number 3. As simple as that, right? Now, if you see that this signal has started from here, right? Everything is started from this common line. Sorry for this, right? Now, if you see this signal number 1, and if you see this signal number 2, there is a difference, right? They are starting as t is equal to 0, t is equal to 1 second. Both are starting at the 1 second, right? But just try to understand, in the second signal, we do not have, we are starting from right here, from the top. These 90 degrees are gone, right? We are starting the signal and their 90 degrees are absolutely gone, right? And if that is the case, it's a problem. And what the problem is, if I compare these two signals, they are not the same signal. They are out of the phase. How much out of the phase? They are 90 degrees out of the phase because initial 90 degrees are not here in the second signal. As simple as that. Now, if I talk about the third signal, just try to understand. The third signal doesn't have the starting 90 degrees, doesn't have these 90 degrees from here to here, right? It is starting from here at t is equal to 1 second, right? It means that, what is the meaning? The meaning is it is out of phase. But is it out of phase 90 degree? No, it is out of phase 180 degree because this portion is not there at all. The signal is starting right from here. This is 180 degrees out of phase. And now you must be thinking, Mr. Vishnu, we got this. But what is the practical use case? Believe me, when we talk about phase modulation, if you know this, you can get it very easily. But if you do not know this, it is going to be a problem, right? So I am just summarizing. We need to understand the medium. Some guys came and tell you can understand the medium if you understand it as a wave. We saw the entire spectrum. And we find that we can see only the little portion of the spectrum, which is the visible light. There is a huge spectrum, right? Then we studied this wave well. We understood wavelength, frequency, amplitude, and phase. We understand that if you multiply frequency and wavelength, it is going to give you speed. And most of the electromagnetic waves in vacuum, almost every electromagnetic wave in vacuum will go at a speed of 3 into 10 to the power 8 meter per second or 3 lakhs kilometer per second, right? See, it's huge. Having said that, although I have created a huge board for today, but we are not able to complete it, and I do not want to bombard you with so many concepts. My request is you just go through these concepts once again. And by the way, we will be meeting tomorrow also. Although the class timings are different, right? Days are different, but because we are a little bit behind, we will be doing class tomorrow also. Okay, having said that, this is what I wanted to explain you till now, in today's class. If you have any doubt, any question, please do ask. Anyone? Okay, at least tell me, are you able to hear me? Anyone?
Yeah.
Hi Vishnu, I'm audible.
Yeah, perfect. Naveen ji, please go ahead and ask your question.
Yeah, so somewhere you have mentioned we can see two frequencies. One is 2.4 gigahertz and another one is 5.77 gigahertz.
Yeah.
But normally what see the band types are one is 2.4 gigahertz and another one is 5 gigahertz. So that's what I just wanted to clarify. It's 5 gigahertz or 5.7
I
gigahertz.
will be talking about it because it is not exactly the 2.4 gigahertz frequency. It is actually the range, right? And do not worry, when we talk about
Right.
channels, I will be talking about it. But it's a great question. I mean, anybody else?
Thank-
Sir, here, Gautam here.
Yeah, Gautam, just one request. If you can raise your hand first, then I would be knowing it and it is going to be easy for everybody. Yes, Gautam, please go ahead.
Yeah, so for example, like if we have one access point, so the coverage of the access point will be determined by like which thing? So it depends on like say amplitude or how it will be.
Yeah, so believe me, till this point, we have only half knowledge of the coverage. Only half knowledge because we have just studied some parameters, right? Only amplitude, frequency, wavelength, and other things, right? But if you want to understand the coverage, we need to understand the antenna patterns also. We need to understand how various vectors like refraction, reflection, diffraction, and so many other things, right? Which we are going to cover in tomorrow's class. Believe me, after two classes, all these concepts are going to be absolutely clear. Then on what basis we are going to define the coverage of access point. But till at this point, we do not have enough information, Mr. Gautam. Okay.
Yeah, okay. And yeah,
Mhm.
okay. And another question, like if we pass the alternating current to the antenna,
Mhm.
so we will receive only the radio waves. Like we will
Yeah,
send
it
only the
depends.
radio waves.
It
So will
depends on
that be
this AC signal. Okay. And believe me, if you are giving this antenna the AC signal of 2.4 hertz frequency, it is going to produce 2.4 hertz radio waves. But if you increase the frequency, it is going to generate other signals also. But in radio communication, this 2.4 gigahertz license was free, and that is why we are using it for the wireless communication. We are going to stick to that. But Mr. Hertz experiment can produce other waves also, depending on this electric or the alternating current frequency. Mr. Gautam.
okay? I got it. Yeah, okay, got it. Thanks, Vishnu.
Perfect. Nitin, Mr. Nitin, I think you have some.
Hi,
Yeah.
hi, Vishnu.
Mhm.
Thanks, actually, it was almost a open session. I just have one request. Can you mention some like highlighted topics because it was a great session, so I can do some my own work like you have mentioned about the waves and all those things. So it
Nitin,
will be
absolutely. Means I'm so sorry, but your voice is not that clear. Sometime it is coming good, but sometime it is. Can you please repeat the question, maybe slightly in louder voice?
1 second. I'm audible.
Yeah, you are, but sometime your voice is pretty clear.
Okay.
Sometime it goes down. Yeah,
Sorry for it.
no
Like
problem.
I just want to mention that it was almost eye-opener session
Mhm.
because I was definitely not aware about those basic things, and I definitely missed that. So just want can you mention some specific topics where on those I can work on like just like my homework so I can be ready for the next session.
Oh, you will be ready for the next session. Okay. Actually,
Yeah.
believe me, I prepare all these boards on the fly, right? See, I
Oh,
know all means on the fly means just before this, maybe 2 or 3 hours before this session, I just make this
okay.
sessions, right? So, but before that, I read. It is not like that I am not reading things
Hmm.
because I see these problem in many wireless. So I deal with many wireless engineer in my team, right?
Hmm.
We face these
Truly.
problems because people understand that okay, if I make this 2.4 gigahertz, then basically this much with the frequency, this much with the wavelength, but nobody understand what exactly happening behind the scene. And do not worry, Nitin, if you just attend this session with means with approximately 80-90% concentration, there shouldn't be any problem.
Mm-hmm.
Do not worry about, we will go slow, means
Okay, okay.
starting 5 or yeah.
That will be great. Thank you. Thank
Because I understand this is a problem with everybody. Means I am not a wireless
you.
engineer, but still, I would like to tell you all these things so that we will be better network wireless engineers. We all are learning along with each other. Yeah,
Thanks, Vishnu. Thanks.
perfect. Anybody else? Any other question? And thank you so much for praising that this session was good. Thank you so much, Mr. Nitin. Yeah. Anyone else? Okay, so bear with me. These sessions are going to be a little bit slow, but it is going to be really, I will try to make whatever things people say are not interesting. Next class, when you read about reflection, refraction, diffraction, it is going to be mind blowing. Mr. Gautam, please go ahead.
Sir, so these recording sessions will be accessible for us for today class. It will
Absolutely.
be
By
accessed by
12 tomorrow, it will be uploaded on the website and you can read about it. We need at least 12 hours.
Okay.
Yeah.
Yeah. Okay. Thanks.
Perfect. Okay, then, guys. Thank you so much for being a wonderful audience. See you tomorrow. By the way, we have class tomorrow also. Bye for now.
Okay. Thank you. Thank you.